Hey guys, today we're going to talk about two really special things in a circle, and that is something called the central angle, and we'll talk about arcs as well. So we'll use this little circle right over here. Our friend's going to go away. So the first thing we're going to talk about is the central angle. So let's say we have a circle, just like this, and let's say we have our center is right here, and we'll call this point B. So this will be circle B. Then we'll have point A and point C. So the first thing we're going to talk about is a central angle. Now the central angle of a circle is going to be an angle that is formed by using two of the radii of that circle. And your center is going to be the vertex of that angle. So like right here, say you have a measurement of x, but angle ABC would be a central angle of circle B. Now let's say we have, and actually we're going to take that x away. Let's say we have, just for this, say we have another radii coming out, and let's say we have angles 1, 2, and 3. From what we know about circles and what we know about angles, if you add up all these central angles, so here we have measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, they're going to add up to 360. So all the central angles in a circle have a sum of 360. And that's in degrees. Now whenever you make a central angle, I'm going to take this part away over here. Whenever you make a central angle, the 2 points that you intersect at, A and C here, they also form what we call an arc. It's going to be the arc of the circle. So an arc, we'll say arc AC, which would be notated like this, is going to be like part of the circumference of the circle. This red part right here. So that part of the circle, we call that an arc. Now there's different types of arcs. So this one, I'll bring that x back, this one we would call a minor arc. So our minor arc here, AC, if we want to find the measurement of that arc, what we would do, our measure of arc AC, it's just going to be equal to the measure of the central angle that also forms that arc. So the measure of angle ABC, which is, in this case, x. So if this measure of this angle was 80 degrees, then this arc, we would say its measure is 80 degrees. Don't let that confuse you with something we're going to do in the future called arc length. We'll calculate how to find the length of that, but right now we're just going to do its measure is, in this case, x. So that's called a minor arc. Now, with a minor arc, there's also something called a major arc. And if you look at the same central angle that we have here, we have arc AC, but we also could have the arc that's kind of formed on the other side going around. So we could have this arc that's not the smaller section here, but the longer way around. And that would be an example of a major arc. But in order to name that, in order to notate it, we can't call that arc AC because we wouldn't know which one is which. So we need to find another point, like on this longer path here, we'll just say down here, point D, and we're going to have to use that when naming. So for a major arc, we would call it arc, and it's going to be ADC, because you would go from A to D to C around. So ADC, that would be the major arc here in relation to this central angle. Now if we want to find the measure of this arc, what we're going to do, so the measure of arc ADC, instead of being equal to the central angle, it's equal to 360 minus the central angle, the part that's left over. Or you could say it's equal to 360 minus this arc up here if you want. It's equal to the whole 360 but minus this part, which again you could say is 360 minus that central angle of x. So ADC, that would be a major arc here. And our last possibility for an arc is something we should be familiar with, something called a semicircle. And a semicircle, well, that's going to be if you have, like, you have the diameter going straight across here. And we'll call this point E. So a semicircle, that's going to be, or that's going to have a measure, that arc, the measure of arc EAC, you can say, that's going to equal 180. Always for a semicircle, it's going to equal 180, because it's like halfway, your central angle would be 180 degrees. You're cutting the circle into 2 equal halves. So we have a minor arc, we have a major arc, and we also have a semicircle that's possible. Now with arcs, there also comes some other special relationships. One of them is congruent arcs. So if you have 2 circles, or if you have 1 circle, so if you have 1 circle, or if you have 2 congruent circles, we'll just stick with 1 now. And let's say you have, we'll try to make this accurate. Let's say you have these 3 angles, angle 1, angle 2, and angle 3. And we'll list our points on the outside, simply A, B, and C. If we know that angle 2 is congruent to angle 3, so if we know angle 2 is congruent to angle 3 here, then we know the arcs are both congruent as well. The arcs formed by those central angles. So if angle 2 is congruent to angle 3, then we're going to know arc, not AC, arc BC, this arc right here, is going to be congruent to arc BA, or AB. So if the central angles are congruent, then the arcs will be congruent as well. And also that works backwards if we know the arcs are congruent. So if we have arc BC is congruent to arc BA, then we also know the central angles will be congruent as well. So that's congruent arcs. That's actually a theorem, page 707 if you want to copy down the theorem word for word in your book. And then we're going to talk about adjacent arcs and this little postulate, and then we'll do a little practice with these. So if you have adjacent arcs in a circle, draw our best circle here. So if, let's say we have point A, point L, point K, and point C. So let's say we have all these radii drawn, and we have arc LK and we have arc KC. The relationship between LK and KC is we would call these adjacent arcs. Now adjacent arcs, they have one point in common, so in this case their point in common is K, and that's going to make them adjacent, which is going to lead us into a nice little postulate called the arc addition postulate. And what this is going to say is, for this example here, the measure of arc LK plus the measure of arc KC, well, that's going to be equal to the measure of arc, and I'm just going to call it LKC here, going through these. So if you have 2 arcs being added together and they make up a larger arc, their measures added together will equal the larger. And that's your arc addition postulate. Alright, that's all we have for today. I'll give you some practice problems to try, just really getting the vocabulary down here and finding some different measurements. Have a nice day, guys.